Welcome to another Explainer. I'm absolutely thrilled to have you here today because we're tackling one of the most essential, yet honestly frequently misunderstood aspects of software engineering. Today, we're diving deep into the critical art of securing your backend APIs through validations and transformations. So if you've ever wondered how modern applications keep their data clean, secure, and running smoothly behind the scenes, you are in the exact right place. Let's get into it.
To kick things off, let's think about this. Why might a perfectly coded, beautifully architected system suddenly just break and crash, all because a user typed a number instead of a word? I mean, it sounds kind of absurd, right? The code itself has no bugs, the servers are online and humming along, but a simple typo from a client literally brings the whole thing to its knees.
Well, here's what happens. When that unexpected data slips past the entry point and hits your database, say it's trying to insert a numeric 0 into a Postgres column that strictly expects text, the database query fails. And what happens next? The server completely panics. It throws an ugly 500 internal server error right back at the user. It's basically the server throwing its hands up and saying, something went wrong and I have absolutely no idea what to do. That is an incredibly poor user experience, and it's exactly what we're going to prevent today.
To understand how we stop these crashes, here's our roadmap for today. First, we'll look at the backend layer cake. Second, the validation gatekeeper. Third, flavors of validation. Fourth, transforming the data. And finally, front-end versus back-end validation.
Okay, Section 1, the back-end layer cake. Let's dive right in by looking at how our systems are actually built from the ground up.
You can think of a typical backend like a layer cake. First, data arrives at the controller layer. This is the main entry point that handles all the HTTP-related stuff, routing the request and deciding what status code to return. The controller then passes the baton down to the service layer. This is really the brain of the operation, where all your core business logic lives, stuff like sending emails or triggering webhooks. Finally, the service layer talks to the repository layer at the bottom, which handles the actual database queries, the insertions, and the deletions.
Moving on to Section 2, the validation gatekeeper. The million-dollar question we need to answer is, where exactly in this cake do we check the data?
Notice the dramatic difference a gatekeeper makes here. This validation pipeline sits right at the controller layer, acting like a strict bouncer before any significant business logic is ever executed. By intercepting data at this entry point, we completely avoid that chaotic 500 server crash. Instead, if a user sends a number instead of a string, our gatekeeper politely but firmly rejects it with a 400 bad request. It just tells the client, hey, the data you sent doesn't satisfy our constraints. Please fix it and try again. It keeps our entire system from entering an unexpected broken state.
All right, Section 3, 3 flavors of validation. What exact rules is this bouncer enforcing to keep things secure? Let's explore.
First up, we have syntactic validation. This one is all about structure. For example, the algorithm checks if a string provided for an email actually looks like an email. Does it have an @ symbol? Does it have a valid domain at the end? Or for a phone number, does it have a country code followed by 10 digits? Syntactic validation ensures the structural formatting is exactly what the API expects it to be.
Next, we have semantic validation. Now, this one is fascinating because even if the data's syntax is perfectly formatted, it still might be utter nonsense in the real world. Semantic validation asks, does this data make logical sense for our specific application context?
These examples brilliantly illustrate why semantic checks are so crucial. Imagine your API accepting a perfectly formatted date of birth, but the year is 2026. Unless you have actual time travelers using your app, a birth date literally cannot be in the future. Or look at these ages. 430 years old? 365 years old? An age of 430 might be structurally a valid number, so it passes syntactic validation. But semantically, it makes zero sense for a human user today. The validation pipeline must reject this because, well, logical age limits usually cap out around 120.
The third flavor is type validation. Backend databases and programming languages are incredibly strict about data types. This simply confirms that a string is actually a string, a number is truly a number, a Boolean is a Boolean, and an array isn't just a random stray word. Before we move on, I should definitely mention that these pipelines can also handle some pretty complex logic, specifically checking cross-field dependencies. For instance, ensuring a password field and a confirm password field identically match. Or, let's say a user checks a box saying married is true, the pipeline can dynamically enforce that a partner name field must now be provided.
Now for Section 4, transforming the data. We've successfully kept the bad data out, but what do we actually do with the data we let in?
Well, the server has to clean up that user input before passing it down to the business logic. Let's look at this. For example, when a user sends a query parameter like page2 in a URL, it naturally arrives as a text string, but our database expects a number. Transformation forces that string into a proper number type. We also transform chaotic uppercase emails into a standardized lowercase format and add standardized plus signs to raw phone numbers. We do all of this right at the entry point, so our underlying business logic only ever has to deal with clean, perfectly predictable data formats.
Section 5. Front-end versus back-end validation. We are now arriving at the climax of our explainer, and this covers an area where so many software engineering mistakes happen.
These two concepts are absolutely not interchangeable. Front-end validation, like when a web form turns red immediately after you type a bad email, is purely for user experience. It's just there to give the user quick, snappy feedback. Back-end validation, however, is not about user experience at all. It is entirely about your system's security and data integrity.
Getting this wrong creates a massive vulnerability. You see, an API doesn't just talk to your pretty web form. Anyone can access your API directly using testing tools like Insomnia or Postman. And when they do that, they bypass your front end completely. There is literally no web form there to stop them from sending bad data. Therefore, if your back end relies on the front end to filter out the garbage, your server will break the second the client bypasses the browser. Back-end validation is an absolute, non-negotiable mandate. The front end, that's just an optional proxy.
Which brings us to our golden rule of API design. Never trust the client. Always validate at the server entry point. By setting up a robust pipeline of syntactic, semantic, and type validations, and by applying the necessary transformations before your business logic runs, you ensure your system remains bulletproof. So, I'll leave you with this provocative thought to chew on today. If someone were to bypass your web forms right now and send completely random data directly to your APIs, would your servers gracefully reject it, or would they crash in a panic? It's definitely something to think about. Thank you so much for joining me on this explainer, and keep building secure systems.